Good day, and welcome to our on-demand webinar, an introduction to the Quantile Framework for Mathematics. We're so pleased that you've taken time from your busy schedule to hear this information. This webinar is a collaboration between Metametrics, creators of the Quantile Framework for Mathematics, and the North Carolina Department of Public Instruction. My name is Matt Copeland. I'm the Director of Educator Engagement here at Metametrics, and it's my pleasure to join you today for this quick tour of the Quantile Framework. If, at any time, you have questions about any of this information, please do not hesitate to contact me. I've provided my email address, mcopeland@lexile.com, here on this slide. Let's start with a quick overview of the next hour or so that we have together. We'll begin this webinar by talking about what is the Quantile Framework for Mathematics. And specifically, we'll talk about the two types of quantile measures that are available: quantile measures for students, and also quantile skill and concept, or QSC measures, for math materials. From there, we'll move into talking about how the Quantile Framework for Mathematics and quantile measures can be used. I'll also be sharing with you all some free tools and research-based resources for utilizing quantile measures. We'll finish off our time together today with a few key takeaways to spur you to think about how you might be able to leverage the Quantile Framework for Mathematics in your everyday work. But first, let's take a look at the bigger picture. Nationally, more than 45 million students from all 50 states are receiving Lexile and quantile measures. And they are doing so in two possible ways. One, they are receiving Lexile and quantile measures because their state accountability assessment, as is the case here in North Carolina, has been linked with the Lexile and quantile frameworks, and those measures are reported in addition to the student's scale score. Or two, at the local level, a student's school or district is using an interim benchmark assessment or an instructional program that has also been linked with the Lexile and quantile frameworks. So in many cases, students may actually be receiving multiple Lexile and quantile measures within a given school year. In fact, in addition to the quantile measures reported from assessments and programs at the local level, quantile measures are also available from the North Carolina end of grade and end of course mathematics tests for grades 3 through 8 and high school. Here, you see an example of the North Carolina end of grade, end of course, individual student report with the quantile measure circled in red. With this quantile student measure, we can now quantify the student's end of grade, end of course performance on the quantile scale, allowing us to connect with mathematical materials and resources to drive instruction in the classroom and reinforce new learning at home. To learn more about quantile measures, visit the URL you see near the top of the screen. This page on the North Carolina Accountability Portal contains background information to much of what I will discuss here, and direct links under the Lexile and quantile measures in North Carolina on the DPA website to many of the tools I will share with you today. Across the country, people have come to realize that quantile measures empower stakeholders in various ways. Teachers are able to differentiate instruction and match students to math content at their own unique ability level. Students can connect with content and also monitor and celebrate their own growth. And families become more knowledgeable about student learning and can participate in their child's growth by helping to reinforce and maintain the math learning that goes on in school. So let's dig in and build our understanding of the Quantile Framework for mathematics. For many of you, one of the easiest ways to understand the Quantile Framework for mathematics is through comparing it to Metametrics' flagship framework, the Lexile Framework for reading. Both frameworks share many of the same characteristics. They are both research-based developmental scales that measure both student ability and the difficulty of material. And both frameworks illuminate instructional opportunities to fuel student learning. However, although the two frameworks are similar, it is important to note they are not the same, and in fact, are used in slightly different ways. So, what is the Quantile Framework for mathematics? At its heart, the Quantile Framework is a common scale. Think of a yardstick here, to measure two seemingly very different things, both a student's mathematical ability and the difficulty of math skills and concepts as presented in a variety of different materials: textbooks, activities, games, worksheets, videos, etc. Having that common scale that allows us to measure both student ability and math skills and concepts is a very helpful tool. However, it's important to understand what that comparison tells us. If we were to imagine that a student has a quantile measure that is equal to the quantile measure of a lesson he or she is about to learn, say a 780 quantile student paired with a 780 quantile lesson, we would say that is a perfect match. However, that match suggests the student has the foundational knowledge and conceptual understanding to be ready for instruction in that content. In other words, the Quantile Framework assumes that a math teacher will be working with and providing instruction on those perfectly matched concepts and skills. This is the key distinction between the Quantile Framework for mathematics and the Lexile Framework for reading. While a perfect match within the Lexile Framework targets independent reading, that is, reading done without much involvement from a teacher, parent, or other adult, the perfect match within the Quantile Framework targets classroom instruction. Again, a perfect match between student measures and material measures within the Quantile Framework assumes that a highly effective classroom teacher is present to guide learning, whereas a perfect match within the Lexile Framework targets independent reading. Imagine for a moment that we took the entire body of mathematics learning, from kindergarten all the way through high school, and teased out all of the various fragments of conceptual understanding and all of the various skills a student would need to learn in that time. These various pieces of mathematical learning are what we call Quantile Skills and Concepts, or QSCs. And there are more than 550 QSCs. Each of these quantile skills and concepts has been measured on the quantile scale. So we know how difficult one QSC is in relation to the other QSCs. So, for example, the skill of rounding whole numbers to a given place value has a measure of 410 quantiles. All of these 550 QSCs were identified by looking at state standards for mathematics from around the country and the original standards document from the National Council of Teachers of Mathematics in the early 2000s. As you see here, the QSCs are organized into 6 strands or categories: algebra and algebraic thinking, number sense, numerical operations, measurement, geometry, and data analysis, statistics, and probability. However, these 6 strands are not mutually exclusive. In other words, there is a great degree of bleed over from one strand into another. As an example of this reality, let's take a look at this example math problem. What is the measure of angle A? In answering this question, the human mind must acknowledge and accommodate several different mathematical concepts and skills. First, we must recognize that the triangle in question is a right triangle, and that interior angles of a triangle sum to 180 degrees. These are QSCs from the geometry strand. Second, we must recognize that right triangles include a right angle, which measures 90 degrees. This is a QSC from the measurement strand. Third, we must set up a basic equation that 90 degrees plus 50 degrees plus the measure of angle A equals 180 degrees, and know how to solve that equation. This is a QSC from the algebra strand. And finally, we must calculate the answer of 40 degrees for angle A. This QSC comes from the number and operation strand. So as you can see from this example, even in answering a single math problem, we draw on our learning from 4 of the 6 different strands. And again, each of these various QSCs has been measured along the quantile scale. For example, QSC number 271, used models to investigate the concept of the Pythagorean theorem, has a quantile measure of 1,010 quantiles. So with these measures, we know how difficult one QSC is in relation to the other QSCs. However, the QSCs are not arranged in a strictly linear fashion. In other words, solving 2-step equations may not be the next QSC in the sequence of difficulty following solving 1-step equations. Instead, the next QSC in terms of difficulty may actually involve skills and conceptual understanding from one of the other strands within the framework. In this way, the Quantile Framework for mathematics is not a linear sequencing of skills and concepts to be learned, but rather a rich tapestry of mathematics learning, representing the weaving together of all these various strands and QSCs throughout a student's K-12 learning journey. The 550 plus QSCs are also organized into what are referred as knowledge clusters. Think of these as mini learning progressions within the mathematics curriculum. They tease out how specific mathematical concepts and skills build upon one another over time. For example, if our focus for a particular lesson is on teaching students to calculate the area of a circle, we need to understand the foundational concepts and skills a student should have under his or her belt before learning about today's focus. And if today's focus is on calculating the area of a circle, it would stand to reason that a student should already understand and be able to work with the concepts of radius, circumference, and pi. We refer to these foundational pieces of learning as prerequisite QSCs. They represent the content that should come before today's learning focus. Similarly, there are also what are referred to as impending QSCs. These are skills and concepts that will come at a later date, where the learning of today's focus will serve as a foundation. For example, if today we are learning about calculating the area of a circle, an impending QSC will involve calculating the area of a cylinder. Understanding the sequencing of these discrete mathematical concepts and skills helps us to better understand our math curriculum and better plan for instruction and learning. A good metaphor for the structure of these knowledge clusters is that of a tree, where the trunk of the tree represents the focus of today's lesson. The roots represent the prerequisite QSCs of foundational learning that should have come before, and the branches and leaves of the tree represent the impending QSCs of future learning. Notice here that the structure of these knowledge clusters is not one-to-one, but rather one-to-many. Each focus QSC may have a whole host of prerequisite and impending QSCs. For more information about the structure and formulation of the knowledge clusters within the Quantile Framework, please visit the URL you see here on the screen. Now that we've established our understanding of what the Quantile Framework is, let's talk a bit more about how it can be used. In the classroom, teachers can utilize quantile measures to examine the difficulty of materials and the prerequisite and impending QSCs within each knowledge cluster to sequence learning activities throughout the school year. In fact, I will be demonstrating an example of doing just this here in a few moments. Teachers can also utilize the knowledge clusters and QSCs to reteach or pre-teach prerequisite concepts and skills to help prepare students for success with specific new learning opportunities. Also, teachers can utilize the knowledge clusters and QSCs to identify aligned resources for remedial and enrichment activities for students. I will be showing you an example of this idea as well shortly. Although the Quantile Framework is geared for instruction, as we discussed before, it can certainly be utilized by parents as well. Here, however, the focus is not on teaching students new math concepts and skills, but rather to reinforce and practice the math already learned at school. In this way, parents can have a profound effect on developing their child's fluency and automaticity with mathematics. Like teachers, parents can use the Quantile Framework to identify games, activities, worksheets, and other resources to target specific mathematical concepts and skills that have already been taught. Parents can also celebrate their child's success by watching the growth in their child's quantile student measures from kindergarten all the way through high school. And finally, parents can use the Quantile Framework and the aligned activities and resources it includes as a common language to discuss mathematics and learning with their child's school and teachers. To summarize, quantile measures can be leveraged in a number of ways by educators, parents, and students. They can be used to link student ability and the difficulty of math content, forecast a student's success rate with that content, differentiate instruction for students of diverse abilities, and of course, track student growth and learning over time. A number of free tools and resources for the Quantile Framework are available on the Quantile's website. To access these tools and resources, please visit hub.lexile.com. Once there, you can find the specific tool you are looking for by clicking on the Math Resources in the left-hand navigation bar you see on your screen. Among these free tools and resources for the Quantile Framework are 1. Fact sheets and frequently asked questions to learn more about quantile measures. 2. The Find Your Textbook tool that allows educators, students, and parents to see both the quantile measure and targeted resources for every lesson in your math textbook. 3. The Math Skills Database that shows the alignment between the Quantile Framework and your state standards for mathematics. 4. The Quantile Teacher Assistant to help teachers differentiate instruction. 5. Math at Home, a resource for parents to help support their child's math learning. And 6. The Summer Math Challenge, an email-based program to help students maintain math skills over the summer months. I did want to take just a few moments to highlight and introduce a few of these tools and resources for you. First of all, a handy user guide is available for 3 of these tools: the Find Your Textbook tool, the Math Skills Database tool, and the Quantile Teacher Assistant tool. This guide offers step-by-step instructions to help educators make use of these 3 tools and summarizes why they may be helpful in classroom planning and instruction. Please visit the URL near the top of your screen to access this guide. One of the most useful Quantile tools for teachers and for parents is the Find Your Textbook feature on quantiles.com. You can access this tool by visiting the URL near the top of the screen. You may want to pause this video and follow along in your own browser. Here, you can enter the title or ISBN number of the majority of math textbooks on the market and navigate to a table of contents page for that textbook. So, if I am teaching Chapter 2, Lesson 4 tomorrow in class, or if I'm the parent and my child asks for help with her homework for Chapter 2, Lesson 4, I can click on the Show Related QSCs link and see which QSCs are addressed in that particular lesson, the quantile measure of that QSC, and how many aligned resources are available for that QSC. Then, I can drill down even deeper by clicking on one or more of the QSCs themselves. Here, I can see the QSC detail page that shows me the QSC ID number, quantile measure, which strand that QSC comes from, and a short description of the content. Below this basic information, I can also click on the links to see the related QSCs in the knowledge cluster, what aligned resources are available for that topic, and even which of my state standards align to this particular QSC. In this way, teachers can find information and resources to plan and differentiate their instruction, while parents can find additional information and resources to reinforce and practice new learning at home. Another key quantile tool is the Math Skills Database. As I explained earlier, it is really the knowledge clusters and their associated QSCs that form the backbone of the Quantile Framework. The Math Skills Database provides a teacher the same access to the QSC detail page and aligned resources, but allows us to access this information from a different starting point: your state standards for mathematical learning. Visiting the URL near the top of this page brings us to a page where we can identify our state standards, already populated in the tool, the grade level, and the specific standard for which we are looking. Again, you may want to pause this video and follow along in your own browser. So for example, if I identify North Carolina as a state, grade 4, and standard NC.4.MD.3, I can see that QSC 192 and QSC 1018 are both aligned to this standards statement. And clicking on either of those two QSCs takes me to that QSC detail page where I can find that same additional information about the QSC, its knowledge cluster, aligned resources, and additional standard statements aligned to the QSC. I can also click on the keyword search feature to search by keywords, QSC number, or quantile measure, and I can even filter results by strand. So, if I enter equations, I can see not only all of the various QSCs that involve equations, but I can also toggle over to the resources and see a kind of master list of all the aligned resources that involve equations. The Math Skills Database helps teachers locate resources aligned to QSCs that support differentiated math instruction to best meet the needs of our students. The Quantile Teacher Assistant also provides teachers access to this same information, but in a slightly different manner. Here, we view the Quantile information and resources through the lens of a classroom full of diverse students with diverse mathematical abilities. You may want to pause this video and visit the URL near the top of your screen to follow along. We begin by using the pull-down menus to identify our state, the grade level, and the specific standard statement we are addressing. Again, we'll use North Carolina, grade 4, and standard NC.4.MD.3 as our example. From this second screen, we can identify the range of quantile measures within a class, or even a subgroup within a class. Doing so allows the system to color code the various QSCs within the knowledge cluster. Green for QSCs below students' designated quantile range. Gold for QSCs within their quantile range. And red for QSCs above their quantile range. Also, by clicking on the More link within each QSC box, teachers can access and explore the available aligned resources for that particular concept and skill. The Quantile Teacher Assistant helps us to better understand the relationship between the difficulty of mathematics content and the abilities of individual or groups of students, and then find aligned resources to supplement our instruction. Similarly, Math at Home is a quantile tool designed for parents and other caregivers. By visiting the URL you see here near the top of your screen, users can enter their home state, grade, and ability level, expressed either as a quantile measure if they know it, or by answering a simple Goldilocks question. Does your child find math at his or her grade level to be easy, hard, or just right? Users can then enter keywords and receive a list of possible resources for their consideration. Again, Math at Home is a great way to encourage families to build students' math fluency and automaticity by having them practice math up to their current quantile measure. Finally, I'm thrilled to introduce Metametrics' newest utility, the Quantile Growth Planner. With this tool, educators, parents, and students can track prior achievement from standardized assessments on the quantile scale and forecast future growth through middle and high school on the quantile scale as well. The graph on the left-hand side of your screen represents a hypothetical 7th grade student. We see the 4 data points representing quantile measures in 3rd, 4th, 5th, and 6th grades. And in the background, we see the wide arc representing the pathway to math readiness for college and career. That idealized range where we'd like to see students perform so that we can say with confidence that this child is working toward being college and career ready. For this imaginary student, The system also forecasts growth through middle school and high school, represented by the black dashed line. If we follow this dashed line to its end, we see that this child, if learning continues at its current pace without intervention or remediation, is forecasted to graduate high school with a quantile measure of about 1100 Q. That measure falls below the goals of college and career readiness. The thin, darker blue line, extending from the last data point then, represents the additional growth this student would need to accumulate over those middle and high school years to graduate college and career ready. The Quantile Growth Planner is a great conversation starter for educators, parents, and students to begin thinking about their own post-secondary goals and the learning plans that will accomplish those goals. But the Quantile Growth Planner goes a step farther. By clicking on the Add Edit Careers button, a student can identify up to 3 possible occupations at a time to compare his or her forecasted growth against the mathematical demands of entering their first year in that occupation. In the example here of a machinist, we see that the math materials first-year machinists engage with range from about 880 quantiles up to 1240 quantiles. Again, as the students are exploring their career goals and interests, this important information helps them to create the plans to spur their own growth towards success. You too can explore the Quantile Growth Planner and see the mathematical demands of almost 400 careers by visiting the URL near the top of your screen. And here at Metametrics, our college and career research continues. The math demands of additional occupations will be added to this tool as they continue to become available. To summarize the key takeaways from our time together today, quantile measures allow us to examine the relationship between student ability and the difficulty of a wide variety of math materials. We also have access to a host of free tools and resources to leverage those quantile measures to differentiate instruction and connect students with materials at their own unique level. Because they span many different assessments and the entire K-12 student experience, quantile measures also enable us to take a more longitudinal view of growth toward the goal of college and career readiness. And finally, quantile measures and the Quantile Framework allow us to communicate more effectively with families and communities about their child's learning. I want to thank you all for joining us today to hear this quick introduction to the Lexile Framework for Reading. On behalf of Metametrics and the North Carolina Department of Public Instruction, thank you so much for your time and your attention to this information. If we can be of any assistance in helping you utilize the Quantile Framework for mathematics, please do not hesitate to contact us at the information you see here on your screen. Thank you all very much for attending, and have a great rest of your day.